functions. Hey, we are starting our new unit. We've got our Unit 8 trig. This is the second part that we're going to be learning. So we're going to be applying all those things that we've been learning, but we're going to be doing it on a coordinate plane. And we're going to get into a little bit more detail. So this is kind of, don't forget, we need to know these things. So the tangent of 60 degrees, so if we make that 60, then this is the square root of 3, and we got tangent, which is the adjacent. So we end up with the square root of 3. Then we've got, this is 1, square root 2, 1, and that is going to be secant. Secant is the reciprocal of cosine, which is adjacent over hypotenuse, so it's going to be the hypotenuse over adjacent. So we've got this, and then we have cosecant, which is the reciprocal of sine, and that is going to be, that will be the hypotenuse over the opposite, which is 1, so we just have 2. So that is the answer. Oh, I forgot to put a 2 here. Okay, now what I'd like you to do is get this in your notes. So we have that we are going to let x and y be points, that any point on the coordinate plane that is other than the origin on the terminal side of an angle, theta, and standard position. Now remember, standard position is where you start at 0 and then you go to your angle. So before we were saying, hey, draw this angle, so let's draw the angle 120 degrees, where you draw that angle and then we would draw the ray, we would draw that terminal. The ray is the terminal side. So we are going to be doing that. So that's what we're doing. So go ahead and get this in your notes, and we are going to do that. We are going to be calling, so we would say that this is equal to A, this would be equal to B, and then this would be equal to C. So instead of using A, B, and C, we are going to be using X, Y, and R. They still behave the exact same way, except instead of having these arbitrary triangles that could be anywhere, we're going to have these triangles that are on the coordinate plane. All right. So moving on, we have our 6 trig functions. So a sign doesn't change. Okay? It's still the opposite over hypotenuse. So we have the opposite over the hypotenuse, which is the opposite of this angle theta, or this angle right here. The opposite would be y over the hypotenuse, opposite over hypotenuse. Okay, cosine is still adjacent over hypotenuse. So your SOHCAHTOA is not going to change. So again, tangent is that opposite over hypotenuse. Opposite over adjacent. Goodness, I'm having a hard time talking today. Opposite over adjacent. So we're going to have the TOA. So SOHCAHTOA. So opposite over adjacent. Okay, our reciprocals are exactly the same. All right. So if we were to draw this, so we're going to try this for the first time. If we were to draw this, then we are going to say our point. So let's put our point at 8:15. All right, that's 8:15. And we need to draw our ray that goes through it. So now I'm saying we have we're going to have a ray that goes through the point of 8:15. All right, so we've got that drawn. And then what we're going to do is we're going to turn this into a right triangle. When we turn it into a right triangle, we're going to always draw to the x-axis. So since our point is where it is, we're going to draw down from the 15 and go to where y is 0. So we're going to draw down. So now we have our right triangle. We're going to use that to help us figure out the length. So if my x is 8, that means I went over 8 spaces. And that means I'm going up 15. And now I just have myself a regular old triangle. We can find the hypotenuse, the r. That would be easy. Okay, so let's actually find r. So we know our x, we know our y. So here is our r. So we are going to use the x squared plus y squared is going to equal r squared, right? So we have 8 squared plus 15 squared equals r squared, 64. We end up with 289 equals r. We take the square root of both sides. And we have got that the square root of 17 is, the square root of 289 is 17. All right, so now we have all four. So we want to do the next trig function. So we're going to do the 6 trig functions. And we end up with sine is opposite of our hypotenuse, where the opposite side is 15 and the hypotenuse is 17. Then our cosecant is going to be the reciprocal. Then we have cosine, which is going to be the adjacent over the hypotenuse. And then we have our secant, which is the reciprocal. Then our tangent is the opposite over adjacent, opposite over adjacent. Again, the angle that we're looking at is always going to be this angle right here. So we can move these around, but we're always going to be looking at that angle. It's that angle that's at the origin. And then our cotangent, of course, is the reciprocal. Okay, so if we were going to do -3, -4, this is the way we would draw this angle. So we start in that standard position, we put our point in, we draw our ray, and then we have our angle theta. We draw all the way to the x-axis. So now we have some weird things, though. We've got some negative numbers, and we really haven't had negative numbers before. So we need to find r again, because if we want to find all 6 trigonomic functions, we need to be able to find that. So we are going to say r is equal to the square root of -3 squared plus -4 squared, which ends up being 9 plus 16, which is 25, and the square root of 25 is 5. So our r is 5. So if we're looking at this picture right here, then our trig function is going to be, we'll end up with all of these. Let me get that picture on there for you. Okay, so we have the picture here of what we found. One thing that I'd like you to make note of, we are in the 3rd quadrant, right? And when we're in the 3rd quadrant, you can tell that our sine is negative, our cosine is negative, our cosecant is negative, our secant is negative, but both tangent and cotangent are positive. So that's where you guys are going to learn that all students are going to take calculus. So what that means is, so we type all, if I can do this. So if all students take calculus, in the 1st quadrant, sine is positive, cosine is positive, and tangent is positive. And where it says students in the 2nd quadrant, only sine is positive. So we're at take, what do you think? And we just found that tangent was positive, so only tangent. Only tangent is going to be positive here. And then in calculus, in that 4th quadrant, only cosine will be positive. So all students take calculus. It's not a promise. It's just letting you know that in the 1st quadrant, all of them are positive. In the 2nd quadrant, only sine is. In the 3rd quadrant, only tangent is. And in the 4th quadrant, only cosine. So you could be asked that in the future. So another strategy that you could do is draw a triangle in that quadrant and try to find that sign. So if you can't remember that sine is positive in the 2nd quadrant, you could draw a triangle there, find the sign of that, and see if it's positive or negative. That would be a way to do it. So always try to find a way to do something without memorization, but that will help you. Okay, so we did do this one in class. What we did is we went ahead and just chose a value for x, and we chose 2 just to make things easy, because it says that it's x plus 2y is equal to 0, and x can be any value greater than or equal to 0, and 2 is an easy number. So we chose 2, and then we just plugged it in, and then we solved for we solved for y. Since x was 2, then our points were -1, or 2, -1. So we went ahead and graphed it, and we were going to find all 6 trig. Again, the line that we're going to draw will be from here, always to the x-axis. So right here, my line isn't very straight, but it's there. Always to the x-axis, and we will be looking at this angle right here, even if it is this larger angle. So when we do that, we should get... where's it going? There we go. We get sine. We get the square root of 5 over 5 for sine. Cosine is 2 times the square root of 5 over 5. Tangent was -1 over 2. Cotangent was -2. Secant was the square root of 5 over 2, and cosecant -5. Notice that sine, negative, cosine's positive, secant is positive, cosecant is negative, tangent and cotangent are both negative, and that would fall in line with, if we look at that picture, that falls in line with it being in that third quadrant, right? Or, sorry, fourth quadrant, which would be cosine, and its reciprocal would be the only thing that is positive. Okay, I believe, yes, that is where we ended the day. So if you have any questions, please let me know. We will be moving on tomorrow. We'll be doing reference angles, and we'll kind of get into that a little bit more. All right, have a great day.